Okay, we're doing 6.2a, which is on page 418. And you're going to need that open to copy a couple things down. So I'm calling it Properties of Parallelograms. Your book calls it Proofs of Parallelograms. We're going to be doing both. We're going to be learning the properties and we're going to be doing proofs of the properties. So first of all, the definition of a parallelogram. We now already know that a parallelogram, which is going to give me 2 minus 4 is negative 2 squared, plus negative 4 squared, which again is going to be 4 plus 16, or the square root of 20, or once again, I get 2 radical 5. So let's put down our sides. LO, we said was 6. OV, we say is 2 radical 5. VE is 6. EL, 2 radical 5. Now I need you to go find a protractor, and you're going to do this next part, where you're just going to measure one angle. So I started with angle E. If you have your protractor, you're going to need to make one side really long so you can use your protractor and measure. And mine came out to be about 64, maybe 63 or 64. And then knowing what we know about parallel lines, we know that these same side interior angles are going to add up to 180. So therefore angle L would be 116. And then we've got more same side interior, so angle O is going to be 64, and angle V is 116. Now we can draw diagonals, and we can use a midpoint formula to figure out what the midpoint is. I'm going to call this M in the middle. My drawing's a little bit off. So midpoint formula means I'm going to do the midpoint of L, which is negative 2, 2, midpoint of LV, which is 2, negative 2. So midpoint is add up the x's, negative 2 plus 2, and divide by 2. And add up the y's, 2 plus negative 2, and divide by 2. So that midpoint comes out to be 0, 0. Midpoint of LV is 0, 0. The midpoint of OE is also going to be 0, 0. Now I'm going to go straight to the next page and write down all of the properties. You're going to need to look in your book at page 420. We're actually going to add another property, property 5. So the first property is opposite sides of a parallelogram are parallel. We also saw in our investigation that opposite sides of a parallelogram are congruent. We saw that opposite angles of a parallelogram are congruent. Diagonals of the parallelogram bisect each other. And what we used is property 5. And property 5 says that consecutive angles are same side interior angles, so they're supplemental. So consecutive angles of a parallelogram are supplements. Now we're going to prove some of these properties with proofs. So the first thing I want to prove is in triangle ABCD, I want to prove that the opposite sides are congruent. I'm going to start with being given parallelogram ABCD. Then they're going to say draw, what we're going to do is draw AC 7th. There's going to be 6 and 7. So angle 6, I'm going to say that triangles are congruent. I'm using triangle BAC congruent to triangle DCA, and I've used angle, side, angle. So 6 is angle, side, angle. And then number 7 I'm going to say that AB is congruent to CD, and BC is congruent to AD, and that, number 7, is my CPCTC. These are opposite, and they're congruent parts of the corresponding parts of the congruent triangles, so they are congruent. Okay, my next theorem is taking the same parallelogram. I'm going to be trying to prove that the opposite angles are congruent. So it starts out with parallelogram ABCD given. The next thing is going to be definition. So it's going to say AB is parallel to DC, and also AD is parallel to BC. So we know the opposite sides are parallel. 3 is all 3 of these things. A is a supplement to B is a supplement to C is a supplement to D. So if 2 parallel lines are cut by a transversal, then each of these are same side interior. So then same side interior angles are supplements. Number 4, I'm saying A and C are both supplements of B. So therefore A is going to be congruent to C. B and D are both supplements to C. So then B is going to be congruent to D. And this is the theorem that if 2 angles are supplements of the same angle, then the 2 angles are congruent. Then they are congruent. So we're using things we've learned all year long to do these proofs. Okay, next page, I'm going to draw the next picture, which is again triangle, parallelogram ABCD. And this time I'm trying to prove that AC and BD bisect each other. So they tell me to draw the diagonals, that they have the diagonals AC and BD, and they meet at point M. And that is all given. Step 2 is going to be the definition of a parallelogram. So once again, AB is parallel to DC, and AD is parallel to BC. So we know the opposite sides are parallel. Number 3, they're telling me it's alternate interior. So again, I would write the whole thing out. If 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. I'm going to use this set of angles and then I'm going to use this set of angles. So I'm going to be proving that these triangles are congruent, this one and the one across from it. So I'm going to say angle BAC is congruent to angle DCA, and also angle ABD is congruent to CBA. And that was all number 3, alternate interior. They've got 2 number 3s here. Their numbering is off. So the next one is going to say that opposite sides of a parallelogram are congruent. So we've proved that in another proof, so we can now use it. I'm going to say that AB is congruent to BAM is congruent to triangle BAM and triangle DCM. And that's from angle side angle. Then I'm going to say that segment AM is congruent to segment CM, because they're corresponding parts, and also segment DM is congruent to segment BM. They are also corresponding parts, CPCTC. I can now say M is the midpoint, definition of midpoint. I can say AC and BD bisect each other, definition of segment bisector. Okay, so that's the hard part, doing the proofs. Now using the information from the proofs to do problems is much easier. We have to know, just keep in mind all the properties that you know about parallelograms and see what kinds of equations we can make from that. So in the first one, AB is x plus 3, BC is x minus 4. And then they give the perimeter of this figure, 6x minus 20. Well, we know opposite sides are congruent, so I'm going to make the equation 2 times x plus 3 plus 2 times x minus 4 equals 6x minus 20. Please go to pause this and finish this problem and solve for x. So I did 2x plus 6 plus 2x minus 8 equals 6x minus 20. I did 4x minus 2 equals 6x minus 20. I subtracted 4x from both sides. Then I added 20, and I got x equals 9. For the next problem, they're giving me opposite angles of the parallelogram, and we now know that opposite angles are congruent. So I'm going to set them equal and go ahead and solve for y. So I subtracted 3y from both sides, then I subtracted 4, and then I got y equals 11. In the last one, I'm going to draw the parallelogram, last one on this sheet, RSTU, and then I'm going to draw in the diagonals, and they meet at point X. Then they say Rx is 6x plus 1, and xt is 4x plus 31. So we know diagonals of a parallelogram bisect each other, so they are equal. 6x plus 1 equals 4x plus 31. Go ahead and solve. I subtracted 4x, and then I subtracted 1, and I got x equals 15. In the next problem, this one's just slightly harder because we have x's and y's. But we're going to use the fact that that the diagonals bisect each other, and I'm going to come up with two equations. My first equation is x plus 1 equals y, and my other equation is 3y minus 7 equals 2x. I'm going to set both of these equations. I got x's and y's in both. I'm going to need to use substitution, so I'm going to set both equations in standard form. So I've got x minus y equals negative 1, and negative 2x plus 3y equals 7, if I've done it right. So I'm going to just put them one on top of the other. And I'm going to take my top equation and multiply it by 2. So that would give me 2x minus 2y equals negative 2. I'm going to add them together and get y equals 5. I'm going to go back to this equation. X plus 1 equals y, and we know that y equals 5, and x equals 4. Okay, next problem. Given parallelogram, this one's kind of crazy. They're giving all this information, D, E, H, and N, but there's not that And it says find as many angles as possible if the measure of DEH is 100. So from that, I know that angle N is also 100. I know that angle D and angle E are supplementary. So for now, I'm going to call it angle D is 80. And angle H is going to also be 80. And all of the other information they're giving me, I can't really do much with it. DH is 20, so each of these would be 10. EN is 17, so each of these, EN is 17? Yeah, so each of these would be half of that. This is 9. HN is 9, EH is 15. We don't have right triangles here, so I can't figure out, I can't do much more with it. EN was 17, yeah. So these are each 8.5. But none of that's really going to help me to solve for any other angles. So these are the only angles that I can do. Number 6, we have a parallelogram, and it says that this is, this is 30, this is A, B, C, D. So one equation I can do is 2x plus 5y equals 30. The other equation I can do is that this is equal to this. So this side is equal to this side, and the diagonal is bisected. So 2x plus 2y equals 18. I'm going to multiply this equation by -2, get negative 2x minus 2y equals -18. The top one was 2x plus 5y equals 30. I'm going to add the equations together and get 3y equals 12, y equals 4. Go ahead and substitute in for either of the equations. I'm going to do 2x plus 5y equals 30. So that's 2x plus 5 times 4 equals 30. And 2x equals 10. X equals 5. So you can see that these problems aren't so bad at all. Just knowing how to do substitution is the only problem. Okay, in number 7, we got parallelogram DECK. Angle 1 is 42. Angle 2 is x squared. Angle CED, this whole thing, is 13x. So this whole thing, that whole angle is equal to this whole angle. So the equation I'm going to set up is x squared plus 42 equals 13x. And in order to solve this, since I have a squared term, I'm going to have to set it equal to 0. X squared minus 13x plus 42 equals 0. When I factor, which I can, I believe I get -7 and -6, which gives me two answers, x equals 7 or x equals 6. Well, I'm going to test them out, and they also want me to see what angle 2 is going to be. So if x equals 7, then angle 2, which is x squared, would be 49. And I want to know, is that going to be equal, are these two, angle 1 and angle 2, added together, so angle K, which would be 42 plus 49, would be 91. Is that going to be the same as angle E, which is 13 times 7, which is also 91. So 7 works. Now let me test out 6. So if x is 6, then x squared would be 36, and angle K would be 42 plus 36, which would be 78. And angle E would be 13 times 6, which is also 78. So it gives me 2 answers, and to answer their question, angle 2 could either be 49 or it could be 36. Okay, number 8. These are going to get kind of easy. Find the value of the variables. So I've got an x here and I've got a y. Y, quite simply, is 68 degrees. It's the opposite angle. X plus 6 equals 13. X equals 7. Done. B, y equals 123. For the x, 2x minus 3 equals 37. 2x equals 40. X equals 20. Nice and easy. Same thing with this page, not so hard. As shown, a gate contains several parallelograms. Find the measure of angle ADC when angle DAB, DAB is 65. Well, if it's a parallelogram, those are same side interior angles, so I would just do 180 minus 65, and I get 115. Number 10A, the diagonals of the parallelogram intersect at point W. Find the coordinates. So, coordinates of W. So I'm going to find the midpoint of TV. So T looks like it's like 1.55, and V, I believe I have at 4.5 and 0. So to do the midpoint, I got to call it W. The midpoint is 1.5 plus 4.5 divided by 2. And the other one is 5 plus 0 divided by 2. So this came out to 6 over 2 and 5 over 2. So using those 2 coordinates, I get 3 and 2.5. And I could do the same thing for S and V. This one's a little bit easier. S is 0, 0. S and U, the midpoint of SU. And U is the 0.65. It also comes out to be 3 and 2.5. For the next one, the diagonals of the parallelogram in part B, they intersect at point Z. W, I'm going to use X and V this time. X is 7, 6. V is 0, 0. So I'd have 7 plus 0 over 2, 6 plus 0 over 2. I get 3.5, 0. Number 11, all we're given is that it's a parallelogram. FM is 5, so therefore MH is also 5, and FH is 10. Nice, easy problem.